Okay, so on 4.5, number 25, this is related to rates, so there's going to be a couple different things changing at the same time. It says a balloon is rising vertically above a level straight road at a constant rate of 1 foot per second. So we're talking about rising, so I'm going to call this y. So what that means is dy dt, the change in y, is 1 foot per second. And then it says, just when the balloon is 65 feet above the ground, the bicycle passes under it. So we're going to call this the bicycle, and we're going to call this x. So we're going to say that dx dt, the bike is traveling at 17 feet per second. How fast is the distance between the bicycle and the balloon increasing 3 seconds later? So the distance between, how fast is the distance between the balloon? So from the balloon to the bike, that's that d. So we're looking for dd dt. We want to know that 3 seconds later. Well, let's figure out how far this balloon, or how far this bike traveled 3 seconds later so we can get the x value. So I hope we all know the formula that distance equals rate times time. So this rate is 17 feet per second, and our time is 3 seconds. So I hope you know that the 3 seconds on top with the seconds on the bottom, the seconds reduce. So this is going to just be feet. And let's see, what is that? 51 feet. So that means we're looking for dd dt when x equals 51. Now, not only is the x changing, but the y value is changing. Now, let's see, just when the balloon is 65 feet above the ground. So the balloon is like 65 feet right here. But 3 seconds, that's when the bike is right here. But 3 seconds later, the balloon's going to be higher because it's still rising. So we're going to use the distance equals rate time again, knowing that this bicycle rises 1 foot per second. Well, I don't even need math. I don't need to calculate that. So in 3 seconds, it will be 3 feet higher. So what that means is this y, we're looking for it when x is 51 and when y would be 68. Because again, 3 seconds and it's raising 1 foot per second, and we're doing 3 seconds later, that's where the 68 feet come in. So we are going to take and use this stuff in order to find our dd dt. Well, we have to know that this is a right angle. We're going to say there's no air blowing the balloon sideways. It's going straight up. So x squared plus y squared needs to equal d squared. So doing the derivative with respect to time is going to give us 2x dx dt, because we're doing the derivative with respect to time and not x, plus 2y dy dt is going to equal 2d dd dt. Okay, and remember this, my variable is this part, so I got to be able to plug numbers in for all the rest of this. Now, what I always do on a problem like this is I always reduce everything by 2, because both sides are divisible by 2. So these 2's will all reduce out when you divide both sides by 2. So we're going to plug stuff in. So x, we're looking when x is 51 feet. That's 51 feet. And then dx dt is 17 feet per second. So we're going to multiply that times that. Now this would be feet squared per second, because I'm taking, this is feet. So I'm taking feet times feet divided by seconds. That's feet squared per second. And then plus my y value is 68 feet. And my dy dt is times 1 foot per second. So this foot times foot divided by seconds, that's also feet squared divided by 2, or divided by seconds, feet squared over seconds. So these are like terms. And then over here, we got to find d, and we're looking for dd dt. Well, we don't know what d is right now, except when the balloon gets there, we know this is 68. We know that is 68, and we know this one is 51. So if we take and plug those numbers into Pythagorean theorem, we get 51 squared plus 68 squared is going to equal d squared. So I'm going to take my calculator real quick and calculate that out. And that comes out to be 85. So when you solve this, D comes out to be 85 feet. Glad he made that a nice, pretty number. So we got to stick 85 feet in here. Remember, these two are feet squared, and that's feet. So we're going to combine these two together. So I'm going to take 51 times 17, and that's 867, plus the 68 gives me 935. So I'm going to come down here, and this is 935. Again, this is feet squared per second. And over here, we got the 85 feet. So we're going to multiply each side by the reciprocal of this, 1 over 85 feet. I hope you see that when we put that 85 feet down here in the bottom, this foot will reduce with one of these feet. So we're back to feet per second. That's because this is going to be a rate of change in that distance. So that's good enough for your answer right there. So dt is 935 85th feet per second. Now I'm going to go ahead and do that on the calculator. I could have done it by hand, but it would have taken longer. That comes out to be 11. So it's 11 feet per second. Now, if they'd asked me to tell what that meant in relationship to this problem, it would have been along the lines that the distance between the balloon and the bike 3 seconds after the bike is directly under the balloon is changing at a rate of 11 feet per second. Okay, so that's that problem. Let's see what else we got going on here. Okay, we got number 6 coming up over here. Let's see, it looks like somebody wants me to do 26 on this sheet as well. So I'm going to come over here. I did this one. I think I've already done this one and it's already on Canvas. I did this in class the other day. Somebody asked for this. So you can go back and watch that. It's like on Tuesday or Wednesday of this week. So this one's already on Canvas as well. So we're going to come up here and do number 6. Now this says f of 1 equals -3 and f prime of 1 equals 5. It wants us to approximate these two things using the tangent line. Well, 1 -3 is a point, and f prime of 1, there's the slope of 5. So my tangent line is y plus 3 equals 5 times x minus 1. And they want me to find this. They want me to find two different answers. One when x is 0.99. So for that one, and maybe you ought to put in here f of 0.99 instead of y, so we know that's what we're finding, is going to equal 5x minus 5, and then we subtract, oops, I'm supposed to plug 0.99 in here. And that's going to be f of 0.99 is going to equal, so 5 times 1, 5 times 1 would be 5, right? So this is going to be 4.95. And then I got minus 8 because I'm subtracting that over. So this will be approximately, let's see, it's 5, that'd be -3, so it'd be -3.05. So that would be the approximation of f of 0.99. And then we're going to do the exact same thing, is that we're going to estimate 1.01. So I'm going to do f of 1.01, and then go back up here to use my tangent line. So that's plus 3 is going to equal 5 times 1.01 minus 1. So this is 5 times 0.01. Okay, I'll just leave that. I'm going to go ahead and subtract the 3 over now. I probably should have done that way before. So I'm going to subtract the 3 over here. So let's see, this is going to be 0.05. So this is 0.05 minus 3. So it's going to be -2.95, I believe, if I'm doing my calculation right. So there's your two answers. So those are the estimation of those two things. Does anybody have anything else they want to see off of anything off Unit 4? Okay, there's 7 of you. If y'all tell me you're good, we're going to call it a day. There's 1, 2, 3, 4, 5, 6. Got 1 more. Ann, are you there? Oh, she has already said that. Never mind. Maddie. Oh, that is 7. Okay, so we're there. All right, everybody. Hope you have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I will see you on Monday. Remind me to pass out all of your Unit 5 stuff so y'all have it at home so we can do that over while we're doing virtual stuff. Have a great one. Bye.